Hello and welcome to Apti Plus Academy for Civil Services Preparation. So, in the view of the recent papers of CSAT 2, we have a couple of topics to be discussed. So, selecting a few topics which have become very important in the recent years are topics like permutation and combination, questions based on clocks and calendars. So, many a times people find it difficult, especially when it comes to permutation combination, clocks and calendars, and how these questions can be presented before you in form of a reasoning or a aptitude based question. So, if we go with the recent trend of what CSAT is following, we see that they are asking a lot of questions from the basic principles of counting, which comes under permutation and combination. But people are very much scared and afraid what permutation and combination is, because many of you might not have studied in your junior classes. But let me tell you one thing, permutation and combination is just another name for basic principles of counting, and we need not actually get into what P and C is in order to solve questions that are asked in exam. So, our basic understanding of counting techniques is enough to solve questions on permutation and combination. So, in the due course of the video, we will be talking about that also, but as of now, I am starting with a very basic and an important topic, which is clocks. Now, when you talk about clocks, we talk about an analog clock, in which we will be discussing only the minute hand and the hour hand. We do not consider seconds hand. In most of the questions that you will see in CSAT, they will not consider hour hand, I mean the seconds hand. Even if they consider seconds hand, the concept can be extrapolated. Whatever we learn for the minute hand and the hour hand, the same concept can be extrapolated for seconds hand. So, without much delay, let us start with the topic clocks. So, we will see what is the relevant concept in clock section and how questions can be tackled here. So, when I talk about a clock, as I already told you, we will be talking about a analog clock. So, let me draw an analog clock so that we have an idea what type of questions can be asked and how we can approach it. So, let us say this is an analog clock, this is 12, this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now, my question is, in a 12-hour interval, how many times do the hands of a clock coincide? Number of coincidence or number of meetings. Now, this becomes important for us as the type of questions in the class section is asked. The prerequisite for solving those questions are these concepts that I will be discussing in the next 10 minutes. So, the question is, in 12 hours interval, the number of meetings of the hands of the clock. Which two hands I am talking about? Minute hand and the hour hand. So, how many times do the hands of the clock meet? So, when I ask this question, maximum of us will say it is 12, but it is not 12. We will see how. If I ask you roughly, just give me a rough approximation when the time is between 1 and 2. The time is between 1 o'clock and 2 o'clock. The hands of the clock are together at around 1:05. Likewise, between 2 and 3, the hands of the clock will be together around 2:10. Between 3 and 4, it is together between around 3:15 and so on and so forth. So, what do we observe? That with every interval 1 and 2, 2 and 3, 3 and 4, the hands of the clock are together. So, in one interval 1 and 2, one meeting, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10. Now, if I go with the same pattern, I will say another meeting will happen between 11 and 12 and the next meeting will happen between 12 and 1. But that is not correct. Why? Because if I ask you, when do the hands of the clock meet between 11 and 12, after a little bit of thought you will realize that okay, it meets sharp at 12. It does not meet anywhere between 11 and 12, but it meets sharp at 12. Many a times people will say, sir, it is 11:55. 11:55, the hands of the clock do not coincide. It does not completely overlap. Why? Because 11:55, the minute hand definitely is at 11, but the hour hand does not point exactly at 11. It is somewhat deviated from 11, hence we cannot consider as a case of perfect overlap. Hence, we now understand that the meeting between 11 and 12 happens sharp at 12. Likewise, if I consider the interval 12 to 1, the meeting happens exactly at 12 only. So, we realize that in this 2-hour interval, the meeting happens once. So, 10 times here and 1 meeting here will together make it 11 times. So, the number of meetings in 12-hour interval is always 11. Okay. So, there was a question that was directly asked from this section in CSAT in the previous years. Okay. We will come to that question, but let us first consider the concept. So, 12 hours, the number of meeting is 11. Having understood that, if you focus here, I have written approximated value of the time wherein the hands of the clock are together. But we can actually figure out the exact time, even to the extent of seconds, when the hands of the clock will be together. So, let us see how we do that. So, 12 hours, 11 meetings. So, if I ask you what is the time gap or time interval between any two successive meetings, any two consecutive meetings. So, with basic elementary maths, I can say that it is 12 hours divided by 11. So, 12 hours is what? It is 12 into 60, which is 720 divided by 11. So, 720 by 11. If I just do little bit of maths, I will write 11 6 is 66. I will be left with 60 here. 11 5 is 55. I will be left with 5 by 11. So, this is simple division. 720 by 11. 6 is 66. This is 6. 11 5 is 55. This is 5. So, 65 5 by 11 minutes, I can say. Now, we all agree to the fact that 65 5 by 11 minutes can be rewritten as 1 hour 5 5 by 11 minutes. Agreed? 1 hour 5 5 by 11 minutes. So, now I can say, after having understood this, that the first meeting can be considered at 12 o'clock sharp. First meeting 12 o'clock. After 12 o'clock, the next meeting which we discussed as will happen between 1 and 2, it will happen around 1:05. The exact timing has to be from 12 o'clock. Take a jump of 1 hour 5 5 by 11 minutes. So, 1 hour 5 5 by 11 minutes. This has to be 1 5 5 by 11 minutes. If I want the next time, then again we have to take a jump of 1 hour 5 5 by 11 minutes. The logic here is, if I am supposed to add this number with the same number, 1 5 5 by 11 plus 1 5 5 by 11 would actually mean multiplying this by 2. So, if I multiply this by 2, I will get 2, 10, 10 by 11. If you remember, the time we had taken roughly around 2:10, to be exact, it is 2, 10, 10 by 11. Likewise, if I want the next interval, I will multiply this by 3. It will give me the time between 3 and 4. So, this is 3, 15, 15 by 11. Now, 3, 15, 15 by 11 can be rewritten as, at times, this is an improper fraction. So, what we do is we can write it as 1, 4 by 11. And this 1 can be given to this. So, this becomes 3, 16, 4 by 11. So, if they ask you any interval when the hands of the clock are together, we'll simply multiply it with that number. So, for 4 and 5, I'll multiply this by 4. So, that will give me 4, 20, 20 by 11, which can be rewritten as 4, 20, and 20 by 11 can be written as 1, 9 by 11. Agreed? This 1 can be added to this. So, finally, it will become 4, 21, 9 by 11. So, with this logic, let us again reaffirm whether the meeting will happen between 11 and 12. We did discuss, right, between 11 and 12, the meeting happens sharp at 12. So, mathematically also we can say that if I want to figure out the meeting between 11 and 12, what I'll have to do is I'll have to multiply this number by 11. If I multiply this number by 11, I'll get the interval, I'll get the time when the hands of the clock are together in the interval 11 and 12. So, 1 5 5 by 11, if I multiply it by 11, what do I get? 11 into 1 is 11 and 11 into 5 is 55, and this 11 into this 5 is 55 by 11 again. If you realize this 55 by 11 is 5, so 11 and this 5 when added with this will become 60. So, finally, it is 12. 11:60, 11 hours 60 minutes, isn't it equal to 12 hours or 12 o'clock sharp? So that is what we have, right? So the meeting does not happen anywhere between 11 and 12, but happens at 12 sharp. So this is something that we need to know. Moving ahead with the same, if I talk about the type of question that is asked in the clock section, is generally what they'll do is they'll give you a time interval and they'll ask you the angle. For example, if I say that what is the angle between the hands of the clock, let's say at 4:40. This was one of the questions asked in CSAT. So the question is, what is the angle between the hands of the clock? Angle between hands of a clock at 4:40. So when I talk about the angle between the hands of a clock at 4:40, I need to know two more concepts. That is, how can I find out the speed of the hour hand and the speed of the minute hand? Can we consider a situation and assume that the hands of the clock are running around a circular track at a constant or uniform speed? Can we say that? Exactly. Why? Because the hands of the clock are running around a circular track, you can say, whose entire distance can be considered at 360 degree. So when we have a clock and the hands of the clock are running around this track, can I say the distance covered is 360 degree in one rotation? Now if I ask you, using the formula speed is equals to distance divided by time, can I say that the hour hand covers 360 degrees in how many hours? The smaller one, the hour hand covers 360 degree in 12 hours. So from here I can write down this as 360 divided by 12 into 60, which is how much? This, when you compute, you will get half degree per minute. To solve questions on clocks, this is something that I have to remember, or we can figure it out like this. Likewise, the minute hand completes 360 degrees in how many minutes? Obviously in 1 hour, and 1 hour is equals to 60 minutes. So can I say this is 6 degrees per minute? So these are the two information that I need to solve questions based on this. Now coming back to the question that was asked in exam, angle between the hands of the clock at 4:40. So when you imagine 4:40, you will realize that if I just imagine 4:40, just to get an idea how exactly the angle will look like. So 4 is somewhere here and this is 8, isn't it? So 4:40 would mean this is 4 and this is 8. 4:40 would mean the hour hand will be slightly deviated from 4 and the minute hand can be taken at 8. So we are supposed to figure out this angle. So let us discuss. So when I have a clock, okay, let's say I'll draw a clock again. So this is 12, this is 1, this is 2, 3, 4. Now consider 12 o'clock sharp as the reference. Always consider 12 o'clock sharp as the reference for any angle calculation. So when I have this 12 o'clock sharp as reference, any angle that is to be calculated using this as the reference. Now consider the perfect hour. I am supposed to find out the angle at 4:40, but I will consider the perfect hour, which is 4 o'clock, so as to have a better understanding of the question. So imagine at 4 o'clock, what is the position of the hour hand or minute hand with respect to the reference? So my point is, at 4 o'clock, the smaller hand must have moved how many segments? Now we should understand that one segment is 30 degree. Why? Because total angle is 360 and there are total 12 segments, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12 segments. So each segment the angle is 30 degree. So when it is 4 o'clock, the smaller hand will move 1, 2, 3 and 4. 4 segments. It means the smaller hand will come here. So 4 segments would mean 4 into 30 degree, because each segment is 30 degree. Now at 4 o'clock, what is the position of the hour hand, minute hand? at 4 o'clock the minute hand is pointing at 12 and my reference was also 12. So, because my reference is 12, I can say that the minute hand has not moved any degree with respect to the reference. I am talking about 4 o'clock. Now, let us bring this extra 40 minutes into the picture. What will happen in the next 40 minutes? So, keeping in mind the formula distance is equal to speed into time, keeping in mind the formula distance is equal to speed into time, I can see the status in 40 minutes for R hand. So, if I ask you what is the distance covered by the R hand, you will say speed of the R hand into the time for which you want it to travel, which is equal to 40 minutes in my case. So, speed of the R hand from here I can take half into 40, that will give me how much? 20 degrees, isn't it? So, this is 20 degrees. So, I can say in the next 40 minutes the R hand must have moved another 20 degrees. Talking about this, what about the distance covered by the minute hand? So, distance covered by the minute hand will be speed of the minute hand into the time, which is equals to 40 minutes. So, speed of the minute hand into 40 minutes. What is the speed of the minute hand? 6 into 40 will make it how much? 240. So, I can say this is 240. So, the total distance covered by the R hand is going to become 120 plus 20, which is 140, and the total distance covered by the minute hand is 240. Now, let us plot it. However, you are not supposed to draw these things in the exam. This is just for your understanding purpose. So, I can say the R hand must have moved something like this at 440 and the minute hand must have pointed at 8. So, this angle according to the question is, according to the solution, is 140 and this angle according to the solution is 240. So, ultimately how do I get this theta or the smaller angle? Won't it be 240 minus 140? So, at the end I will say my answer to the question will be 240 minus 140, which is equals to 100 degrees. Now, always understand the purpose for which we are studying. We are studying for an exam like civil services aptitude test, right, wherein speed is not going to be a major concern because you have ample amount of time. So, here you have to develop understanding. So, what these test takers are actually, what these the commission is actually trying to see in a candidate is that whether the particular candidate can understand, analyze and then apply the concepts learned. So, the questions that will be designed in this particular section is not going to test your speed or knowledge, it is going to test your application skills. So, once you are clear with the basics, the question can be twisted, and hence it is always suggested that specifically for an exam like CSAT, you should not be dependent on formulas. Going by the recent trend of the paper, let me tell you, nowadays it is not what it used to be. The paper pattern has changed from being simple formula based questions to logical and application based questions. So, accordingly try to change the approach that you are following for specifically for CSAT, because the entire intention is to check your application skill, and for that the question will be twisted so that the candidate uses his own brain to reach to a particular solution. Okay? So, having understood this, this is the first type wherein the time will be given and the angle will be asked. So, time is given 440 and the angle was asked. So, the angle we calculated 100 degrees. Simple and easy. Moving ahead with the next type, which is just the opposite of this, wherein you will be given the angle and they will ask you the time. Let us take an example. So, the second part is a little bit more interesting and intriguing, because for example, if I say, if I ask you a question in the interval, or I can write it like this, between 4 o'clock and 5 o'clock, the hands of a clock make an angle 100 degrees. find the exact time. Find the exact time. So in this case, between 4 and 5, the angle mentioned is 100 degrees. So the exact time is what? Now, how do we proceed about this question? So we'll say if you talk about the solution, it is going to be 99% same as what we have already done in the previous case. So we'll say let the angle 100 degree be formed at 4t. Now we have been given the interval 4 and 5, right? So between 4 and 5, I can assume the time to be 4t, 4 o'clock t minutes, and I'm assuming that the angle is the angle is 100 degree and the time is 4t, 4 o'clock t minutes. So it's quite clear that I have to solve for t. The intention is quite clear that we have to get the value of t. Now, so let us proceed. Now take this as a fresh question and tell me what will be the position of the hour hand and minute hand at 4t. So at 4 o'clock, if I talk, at 4 o'clock, my hour hand must have moved 4 segments, just like in the previous case. If you see, at 4 o'clock, my hour hand must have moved from 1, 2, 3 and 4 segments. Each segment was of 30 degree. So here also this part is same, and I can say 4 into 30. But in the next t minutes, my hour hand will go at a speed of half into t. Distance will be speed into time. What is this half? Speed of the hour hand. We can have a look at this. Speed of the hour hand is half and speed of the minute hand is 6. So till 4 o'clock, this is the situation. This is the situation till 4 o'clock, and in the next t minutes, it will go half t. At 4 o'clock, the position of the minute hand is again pointing at the reference, which is 12 o'clock sharp. So this has not moved at 4 o'clock, but in the next t minutes, it will move at a speed of 6 degrees per minute. So 6 into t. So how much will this boil down to? This is 120 plus t by 2, and this is 60. Now if you remember in the previous case, what did we do? We calculated the difference. This minus this was equal to 100. So here also, can't I say that the difference should be equal to the angle? So first case we'll write down, it has to be hour hand minus minute hand. So what is the hour hand distance? 120 plus t by 2 minus 60 is going to give me how much? 100 degree, because that is the angle given. So when we solve it, let's see what do we get. So this is 120 minus 100, which is 20, is equals to 11 by 2t. So the value for t becomes 40 by 11. Now 40 by 11 is what? Can I say it is 11, 3s are 33, and this is 7 by 11. So the first time that I'll get, so here I had assumed the time to be 4t. I had assumed the time to be 4t. So when the value of t comes out as 37 by 11, I'll write my time as 437 by 11. 4 o'clock and 3 minutes, 7 by 11. Okay. Now, but if you go back to the previous section of the discussion, we were getting the answer 440, right? 440, the angle was 100. I purposely took that example so that you can understand. Now here, let's have a look. If you see here, I have written hour hand minus minute hand. There should be one more calculation, which is the distance of the minute hand minus the hour hand. That is just the opposite, this minus this. So 60 minus 120 plus t by 2 is equals to 100. Let's see what will I get the value of t from here. So 60 minus t by 2 is 11 by 2t, and this 120 will go that side, will get added, will become 220. This will get cancelled by 20. So the value of t will become 40. So I can say the next time has to be 440. So what do we conclude from this part of the discussion? The conclusion is that any angle, for example, in this case the angle is 100 degree. So any angle in any given 1 hour interval is going to be formed twice. Any angle in a given 1 hour interval is going to be formed twice. For example, in my case, the 100-degree angle is being formed at 4:37 by 11, around 4 o'clock 3 minutes, and this is 4:40, 4 o'clock and 40 minutes. So, twice it is to be formed, and it is quite logical. You can understand. Imagine a situation wherein this is your hour hand and this is, let us say this is your minute hand and this is your hour hand. So, in the first case the time is around 4:03. So, if I can visualize 4:03 will be something like this. This is exact 4 o'clock, imagine this is 4:03. So, the angle is obviously 100-degree. Now, the speed of the minute hand is much more than the speed of the hour hand. So, what this minute hand will do, in the same 1 hour interval it is going to overtake the minute hand, and hence the same angle will be formed again. Okay. Hence, the answer will always be, there will be two answers for the question. So, can I now conclude that any angle will be formed exactly twice in any 1 hour given interval? So, with this I will take up a question on clocks which was asked in last year CSAT paper 2. I will just tell you what the question was. The question was like this, that the hands of the clock, okay, one more thing, when I said any angle will be formed exactly twice in a 1 hour interval, there are two exceptions to this. Not every angle will be formed twice, except two angles, every angle will be formed twice. What are those exceptions? One exception we already know about. If you come back to this, we did talk about meeting. Okay, so when the hands of the clock are meeting, the angle is 0, which we see that we are getting only once in 1 hour interval. For example, between 1 and 2, the meeting or angle 0 is formed at 1:05. But when we go to the next meeting, it is happening at 2:10. It means it has crossed the interval of 1 and 2. Okay, this is between 2 and 3. The next meeting is between 3 and 4. It means it has crossed. So, the exception is 0°. So, first 0° will be formed exactly once in a 1 hour interval, and second, which you might not be knowing because I have not told you, the second angle is 180°. So, except 0° and 180°, all angles, you can write down, all angles are formed exactly twice in a 1 hour interval. So, I can recall two questions which was asked in CSAT based on this. First question was very simple, which said how many times an hour hand and the minute hand of a clock, how many times the hour hand and the minute hand of a clock are at right angle from 1 p.m. to 10 p.m. So, isn't that simple? So, question says from 1 p.m. to 10 p.m. From 1 p.m. to 10 p.m. the angle between the hands of the clock, angle is equals to, right angle means 90°. Now, just see from 1 p.m. to 10 p.m. it has how many hours interval? It has a total of 9 hours interval, 9 hours interval, and except 0° and 180°, every angle will be formed twice in any 1 hour interval. So, can't I say that 90° will also be formed twice in 1 hour interval, and there are total 9 hours. So, the answer should be 9 into 2, 18 times, as simple as that. So, if you know the concept, I do not think this will take you more than 10 seconds to think. So, other than 0° and 180°, every angle has to be formed twice in any 1 hour interval. Taking the same thing forward, the question was asked in CSAT, which is the next question that we have. It says the hands of a clock are at 180° in which of the following time, and the option was given. So, what is the question? The question is hands of a clock are at 180° at which of the following option? First option was given at 7 o'clock. Second option was given at 7:05. Third option was given between 7 and 7:05, between 7 and 7:05, and fourth option was given between 7:05 and 7:10, between 7:05 and 7:10. So this time the hands of the clock are at 180 degree. Now if you remember, 0 degree and 180 degree is formed exactly once. Yes, so what we were saying is between 180 degree, if I am talking about, from 0, only two angles 0 degree and 180 degree is formed exactly once in 1 hour interval. So let us proceed with this question. So if we focus on the question, all the intervals are between 7 and 8. I can say all these are between 7 and 8. So I'll consider the intervals 7 and 8 o'clock, 7 o'clock and 8 o'clock, and let the time be 7t. Okay, so can I say, let us define the position of hour hand and minute hand at 7 o'clock. So 7 o'clock would mean 7 segments, and in the next t minutes it will go half into t, and this has to be 0 plus 6t. So this is how much? This is 210 plus t by 2, and this is 60. So can I take the difference, that 210 plus t by 2 minus 60 is equals to 180. Exactly, right? This minus this, the difference is equal to the angle. So this 180 will come this side, this has become 30, and this will become 11 by 2t. So what is the value of t from here? 60 upon 11. So if I break it into fraction, can I say this is 11 5s are 55, this is 5 by 11, 5 by 11. So what is the time? The time has to be 7 5 by 11. So which of the following option do you think should be correct? Is it 7 o'clock? Definitely no. Is it 7:05? No. It has to be more than 7:05. So that is wrong. Then it says between 7 and 7:05? No. Is it correct? Between 7:05 and 7:10? Definitely correct, because my answer is coming 7:05, 5 by 11. So it is slightly more than 7:05. I hope this makes it easy, right? Now, moving ahead with this, there is one more small concept in the clock section, and after having discussed that small concept in the clock section, we will be starting with the calendar part. So clocks and calendars is a very important part in the reasoning section, not only in CSAT. You talk about any other exam which is aptitude based and has questions on aptitude and reasoning, you will find that questions on clocks and calendars is an integral part of the syllabus. And at the same time, once you have understood, it is very simple and very easy to apply. Okay. So starting with the next type now is the concept of faulty clocks. So we will talk about faulty clocks. Now the clock can be faulty in two ways, either if the clock gains time or if the clock loses time. So when I say clock gains time, I mean to say that the clock is running fast. If I say the clock loses time, means it is running slow. Okay, keep this in mind. So these two are technical terms that you might not be familiar with. So if I say that the clock is gaining 10 minutes per hour, it means every hour the clock is getting some 10 minutes extra time. Now to explain or to understand the concept of faulty clocks, we will start with a very basic question, and the question says that there are two clocks. Okay, there are two clocks, let us say the correct clock and the faulty clock. Both these clocks were set correct on Monday morning 9 a.m. means Monday 9 a.m. I see that the time on both the clocks are same, but then we understand that this particular clock is faulty and it gains 10 minutes per hour. Now the question to this is, will the faulty clock again show the correct time, or will the time shown by both these clocks, one of them is correct and the other one is faulty, will it be same again? If yes, then when? In future, when will that happen? So, this is a very common question that is asked in aptitude based exams including CSAT, that there is a faulty clock, it was matched with the correct timing and later on it was asked that when will it show the correct time again. So, here first of all we have to convince ourselves whether the time shown by the faulty clock will be correct ever again or not. So, just giving an idea, I can say that 9 a.m. this is also showing 9 a.m. correct and faulty show the same time. When the correct shows same Monday, when the correct clock shows 10 a.m., the faulty clock will show how much? It will not go only 1 hour, it will go 1 hour 10 minutes ahead. So, 1 hour 10 minutes ahead will be 9 plus 1 10, 10 hour 10 minutes. So, can I write it as 10 a.m. Next, if this goes 11, this goes 1 hour ahead, this will go how much? So, 10 plus 1 hour 10 minutes. So, when you take it 1 hour ahead, it will be 11:10 plus 10 will make it 11:20. Likewise, when this is 12, this will become how much? 11:20 plus 1 is 12:20 and then this is 12:30. So, this way it will continue. So, now my question to is, will it again show the correct time? If yes, when? So, the idea is very simple. See, it is a very famous proverb that even a stop clock shows the correct time twice a day. Yes or no? So, even a stop clock shows the correct time twice a day. This is at least running fast. So, definitely it will show the correct time, but exactly when? Now, we should understand one thing. If I give you 2 clocks, right, understand this concept. If I give you 2 clocks, in one clock I say this is the time is 6:15, this time is 6:15. Now, I tell you to make this 12 hours ahead, increase the time by 12 hours. So, what will be the time shown by the next clock if it is 12 hours ahead? You will say, sir, same. Why? Because when you talk in terms of an analog clock, a wall clock has got no idea what AM PM is. So, in a wall clock, if I extend the time by 12 hours, the time visible on the clock has to be the same. So, can I now conclude, if 2 clocks differ by a total of 12 hours, then the time shown will be same? Differing by 12 hours would mean one is AM, other is PM. But do you think the clock has any idea what AM PM is? That is our concept, right? When in morning we will say AM, in the evening we will say PM. But the clock has no idea what AM PM is. So, visible time on the clock has to be the same. This is exactly the concept here. So, if you focus on this from 9 AM in the first case, the difference between the 2 time is 0. In the next case, the difference between the 2 time has become 10 minutes in 1 hour. Then the difference has become 20 minutes, then the difference has become 30 minutes. Eventually, this difference will increase, and at some point of time, this difference will become 12 hours or 720 minutes. So, the moment this difference becomes 720 minutes, the time shown here and here will be visibly equal. So, can I now extrapolate and say, okay, in 10 minutes, or like this we can understand it, that the clock gains in 1 hour, it gains 10 minutes, or if you want you can write it like this. The clock gains 10 minutes in 1 hour. Okay. How long will it take to gain a total of 720 minutes? 720 minutes or 12 hours. So, I want it to gain 12 hours or 720 minutes. So, 720 minutes will be gained in 72 hours. Unitary method, 1 upon 10. So, how much time will it take to gain 1 minute? It is 1 upon 10. So, 720 minutes, 1 upon 10 into 720, which cancel and get 72. So, exactly after 72 hours, both the times are going to be same again. Then let us see from 9 AM Monday morning, 72 hours will be complete 3 days. So, from Monday to Tuesday, Tuesday to Wednesday and Wednesday to Thursday, see 24 hours, 24 hours and 24 hours. So, from 9 a.m. Monday to Tuesday 9 a.m. to Wednesday 9 a.m. 48 hours gone, and Thursday 9 a.m. So, on Thursday morning 9 a.m. if you see, this clock will also show 9, this clock will also show 9, and hence the answer to my question is after 72 hours, or in case the answer is given in this form, that Thursday 9 a.m. can be the answer. Right. So, the basic idea behind this is the two clocks will show the same time if they are separated by a total of 720 minutes or 12 hours. That is the basic understanding. So, I hope this makes sense. So, this is what we have in the clocks portion, and having understood what clocks is, we will be discussing calendars, because calendars also, questions on calendars have been very common in the recent years, and CSAT will do a couple of questions which was asked in the exam after having understood the concept. Okay. So, for learning the concepts, interesting concepts on calendars, stay tuned, we will be discussing that in the next part of the video. Thank you so much.